Hi, my name is John Sartori, and I'm one of the professors in the Electrical and Computer Engineering department at the U. One of the most common questions we get from students interested in our program is, what's the difference between electrical engineering, computer engineering, and computer science? Well, these three fields are unbelievably broad and touch pretty much all aspects of our modern world. I'd like to provide an answer to this question in the context of computing systems, which is my area of specialization and one area where these three disciplines meet. In our modern world, computing systems are ubiquitous and extremely capable. We now have handheld computers with sci-fi-like capabilities, and they're gaining new skills all the time. Now, when you think about using a computer, what you usually have in mind is some kind of high-level application, something that you want to do. You want to listen to music, surf the web, or check your email. So there's something that you want to do, but how does your computer actually do these things? The way that your computer actually makes these things happen is physics. Electrons moving around through semiconductors and metals, charging and discharging billions of devices inside your computer. And between the high-level description of what you want to do and the low-level details of how it actually works, there's a huge gap, spanned by many disciplines of electrical engineering, computer engineering, and computer science. So, what do electrical and computer engineers and computer scientists do? We design the systems that make the electrons move around in the right ways so that people can use the applications that they care about. Now, we don't want everyone who wants to check their email on their cell phone to have to understand how all the physics work. So we create many layers of abstraction between the top and the bottom of the compute stack. And electrical and computer engineers work at every level of this stack, designing hardware and software. Let's take a look at some of the layers of abstraction in the compute stack. At the lowest level, we have electrons moving around. This is primarily where electrical engineers would work, building devices to harness the laws of physics and control the flow of electrons in different ways to achieve different fundamental behaviors. Computer engineers take these low-level devices and combine them in unique ways to make circuits and gates that perform simple functions. Then, we combine those simple functions into more complex functions and put them together to create an architecture of a computer. Now, the programmable computer is a very powerful construct that we pretty much take for granted in our everyday lives. The concept is this: when I load a different set of instructions into the computer's memory, it becomes a different type of computer. For example, if I load Google Chrome into the computer's memory, it becomes a web browser. If I load Spotify into the computer's memory, it becomes a music player. So with a well-defined computer, we can transform it into a computer for any task that we want to do, just by loading a different set of instructions into its memory. Now, at the highest level of the compute stack, we have the task or application that we want to perform, like checking our email, for example. So to build an email program, a computer scientist would design different algorithms that do things like search the email or sort the email. These algorithms are the building blocks of the application. We code these algorithms in a programming language, which is a type of computer code that a human can write and understand. Then we compile that code into a set of instructions that the computer can understand. So, from the bottom of the compute stack, electrical and computer engineers build up to a programmable computer that can perform certain operations or instructions. And from the top of the compute stack, computer scientists and engineers work down to generate a set of instructions to load into the computer's memory to make it do what we want it to do. As an electrical engineer, computer engineer, or computer scientist, you can focus on any one of these levels, or more likely, you're going to focus on many of these interconnected levels that interest you. So, electrical and computer engineers take the complex task of performing computations and break it down into levels of abstraction that we can reason about and solve to build more advanced computer systems. Then we put the computer systems that we build into literally everything. From cars to appliances to phones to robots and pretty much everything else that gets created today, there's a computer inside, adding intelligence, collecting data, and controlling our world. So if you want to advance the state of the art and push the boundaries of what is possible in any of these fields, electrical and computing engineering are the fields that will enable you to do that. Speaking as a computer engineer myself, if you want to make an impact on emerging technologies like robotics, self-driving cars, next generation cell phones, machine learning, artificial intelligence, and many more, then I really strongly encourage you to consider computer engineering. Computer engineering gives you a really strong foundation to understand and interface with all the levels of the computing system stack. The skills that you can learn in our computer engineering program at the U of M are always in high demand, and they'll give you the flexibility in your career to do anything you want. Thanks everyone, and I really hope to see you here at the U.